Hey everybody, now we're going to take some time to do some math with significant figures. So I'm hoping by the end of this video you should be able to do some adding and subtracting and multiplying and dividing. For the most part, in chemistry, you are going to have to add and subtract and multiply. You're going to have to multiply and divide more than add and subtract. So hopefully by the end of this video you will know how to multiply and divide and add and subtract using the correct rules for significant figures. So we've discussed all the rules of determining how many sig figs a number has, but now we're going to do some math with those numbers. Okay, realize when we do math with numbers, those numbers can only be as good as the least accurate number. A chain can only be as strong as the weakest link. So if you have something a number that you've measured and it has 8, 10, 12 significant figures, and you do math with it using a number, like multiply a number that only has 1 or 2 significant figures, realize that that the 2 significant figure number is your weakest link. So when you're multiplying and dividing, those rules are fairly straightforward. You count up the number of significant figures in each of the things you're doing math with, and you pick the one with the least number of sig figs, and then you report your answer with that number of sig figs. Okay, so I'm going to show some examples of this in a worksheet. So here's the example number 5. Here's one example. So what we're going to do here is we are going to do this math. 12.0 divided by 15.001. Okay, now when we do this out in the calculator, you're going to get an answer of 0.799. Helps if I write that number, 0.79994666702. Okay, that's what you get. You can't do anything about what the calculator gives you, but you definitely can do something about knowing the science behind these numbers. The number 12.0 has 3 significant figures. This number, 1, 2, 3, 4, 5, 15.001, has 5 significant figures. So when we're doing math, when we're doing multiplication and division, you take the number with the least amount of sig figs, which in this case is 12.0, it's number 3, and so we round our value to 3 significant figures. 1, 2, 3, we round to there, and this means we round it up to 0.800. Okay, and that's your answer. That has 3 significant figures. Now the last thing that we have to make sure we do is put kilograms. We have to make sure that the kilograms work out. So separately, I'm just going to show you if we have kilograms divided by kilograms, notice that those units cancel out, so this number has no units. Okay, so let's try another one. Okay, so now we're going to do multiplication. Let me make sure that you can see this by putting it onto the screen a little bit better here. So, okay, so there's our multiplication. Okay, 1.31 times 2.3. Okay, again, we can do the math in the calculator, and when we do that, we get an answer of 3.013. Okay, now we count significant figures. This one has 1, 2, 3. This one has 2, so our answer can only have 2 significant figures. So in this case, it's 3.0 is how we report that multiplication problem to the correct numbers of sig figs. Our answer can only be as good as the weakest problem. So that's where we get that answer from. Now we look at the units. The units separately would be centimeters times centimeters. They don't cancel out, but centimeters times centimeters is squared centimeters. Okay, so that's our unit. Now we have a number and we have a unit. It's good. Okay, what's the next one? Okay, again, I guess all of these got cut off a little bit. Let me move this up here. Okay, so we plug the number in the calculator. 21 times 6.201. And when we do that, we get an answer. Our calculator gives us an answer of 35.7307821. If you ever give me an answer like that, that's not going to be marked correct, because we can only be as good as the weakest link. So this has 1, 2, 3, 4, 5 significant figures. This has 1, 2, 3, 4 significant figures. So our answer can only have 4 significant figures. All of these other places are only part of the mathematical answer. The weakest link has 4 significant figures, so therefore our answer can only have 4 significant figures. That's as good as our calculations will allow us to do this. So our answer is going to be 35.73. And now the units in this case, again, the units I'm going to take here and here, and I'm going to do the math on the units. So when it's meters times meters, that unit ends up being meters squared, or squared meters. Okay, and now the last one here. Let's go forward and not backward. Okay, so now we have a division problem. Now the division problem is exactly the same as the multiplication problem in terms of determining numbers of sig figs. Multiplication and division have the same operational order. They're equal, so they also have the same number of significant figures. So again, count significant 1, 2, 3, 1, 2, 3. So your answer is only going to have 3 significant figures. So we do the math, 20.2 times 7.41, and we get an answer. Our calculator gives us an answer of 149.682. Now, this provides us kind of an interesting little thing, but we'll do it. 1, 2, 3 significant figures. We have to go to this spot to round. This is above 5, so we have to round up, so we go 150. Now the problem with that is that only has 2 significant figures. Remember, trailing zeros are not significant when there's not a decimal point there. So the way to solve that is by putting a decimal there, and now again we have to worry about units. So our answer is 150, and then units, centimeters divided by seconds. So our answer is going to be 150 and then centimeters per second. That would be the official answer for that problem. When you're adding and subtracting now, it's a different operation. They have different orders of operations than multiplication and division. So when you do this, we have a different rule, adding and subtracting. Okay, and so in this case, you only can report the answer to the smallest place that all the numbers or values, measurements, whatever you want to say, have in common. So again, let's do some examples, and you can see how this works in real life. So again, I'm going to that worksheet that you have access to, and here is a problem with 4 things we're adding together. You can see the directions here. I went out of order in terms of how we're learning, but this is the directions from the worksheet. And so here's what we're going to do. We're going to add these numbers up. Now when we do this, what I do is I add these up to show how this works. Is I do it like we're back in 3rd grade, and we do column math, okay, where we line up all the decimal points and we show this. So it's 12.0. Now these are all added together. Now what is the smallest place that every single number has in common? The smallest place is the 10th spot. So our answer will be reported to the 10th spot. Now you can do math any way you want. You can do this if you wanted to do it by hand. You can do it by hand. I'm going to be doing it in a calculator. And then what you'll see is we get an answer of, change it back to this, you get an answer of 26.281, but again, we want to round it to the 10th spot because that's the smallest place that all the numbers have in common. Even though this is 0, it's still reported, it's still significant, so it still has that in common. So our answer is going to be 26.3. Now, when we have different units and we're adding and subtracting, the only way to do math with units that are different or I'm sorry, the only way to do adding and subtracting is to make sure that the units are the same. You can't just easily add and subtract units with numbers with different units. So in this case, they are all the same. So this is just going to be centimeters. Now you'll notice the next problem here, we're adding, but notice that they're all different units. So we're going to pick one of these and convert all of those numbers to one unit. And I'm going to convert it to meters. So this number, 1.62 meters, is going to stay the same. 1.6 kilometers, that equals 1,600 meters. So I'm going to write that down, 1,600 meters. And then the last one, 1,200 centimeters, that equals 12 meters. Okay, you can go back and look at metric conversions, but when we do that now, we add these up, and we get 1613.62. Well, what's the smallest place that all those numbers have in common? I think that the smallest place is this, the ones place, and so that number is going to be 1614 meters, 1614 meters. Okay, next one. And again, if you want to pause this to try to figure these out before I work through them, feel free to. And so now let's do column math. You don't have to show this work necessarily, but it's a good way for me to illustrate this work. Okay, minus 7.8. Again, smallest place that they have in common. They all have in common the tenths spot, and you'll notice that they are the same unit. So we're going to just do 8.264 minus 7.8, and we get 0.464. Which do we report? We report to this. To the tenth spot, we round up because it's above 5 or above. So it's this, and the units are the same, so it's grams. Okay. And now one more, just for good measure. And again, in this case, the units are the same, so that's good. I'm going to skip over the lining it up this time, and I'm just going to show you the answer. I plug in the answer. The calculator shows me an answer of 4.4168 meters. Okay, but what place do they all have in common? The smallest place they all have in common is the tenth spot. So we would report 4.4 meters as our answer. If you have any questions, feel free to ask me, but there it is, how to do adding and subtracting using the sig figs that we learned about.